Hello and welcome to today's tutorial on the SoftLayer API. I'm Christopher Gallo, the Senior API Developer at SoftLayer, and today we're going to be talking about object filters. An object filter is essentially a JSON object used to restrict and order the API results. So for example, here we have a JSON object. We have property 1, which is itself an object. We have subproperty 1, which is itself an object. And here we have the actual object filter. We say operation and value to check. So this is going to restrict the results of our API request that have property 1, subproperty equal to value to check. So a warning that you need to watch out for: bad object filters are often ignored silently. And so make sure your filter is actually filtering something before assuming it is. And a good way to do that is just invert your object filter and see if the result is changed. And so a requirement: the method should have an object filter listed in the required headers section. Not all API methods can have object filters applied to them, so just make sure it's valid before you apply one. So some basic concepts: we have data types. So while object masks start at the data type returned by the method, object filters, however, are going to usually start at the service of that method. So for example, if you were going to make an API call request to SoftLayer account get virtual guests, your object mask would be a SoftLayer virtual guest data type. Your object filter would be a SoftLayer account data type. So here in our object filter, we're specifying the virtual guest property, which is on the SoftLayer account data type. We say virtual guests, hostname, operation, test hostname. And what that filter will do is give us all our virtual guests that have a hostname that equals test hostname. Unfilterable properties. Count properties can't be filtered. So you can't say make a filter that gives you all the virtual guests that have a certain number of storage nodes or a certain number of users attached to them or anything like that. You'd have to search for specific storage nodes, specific users, and that sort of thing. Relational properties that return a basic value. Basic, I mean like a string, an integer, a Boolean. You can't filter on those type of properties. You can only filter on local properties that have a basic value. So some computed properties also can't be filtered on. The trick here is that these computed properties are not called out in the documentation in any way. So you just kind of have to know that they're computed. For example, fully qualified domain name for hardware and virtual guest is a computed property, and you can't filter by it. You have to filter by hostname and domain name, not by the one property. Also, any property in your object filter should be included in your object mask. Another way to think of this is that object filters are going to control which properties are added to your SQL where and order by clauses when you're making the select statement. So here's a quick example. We're going to call SoftLayer account, get virtual guests. This ID shouldn't be in here, so just ignore that. We have our mask, and we have our JSON filter. So the JSON filter here is a SLCLI way of specifying a filter. And you just put your JSON string just like this. So here, since we're starting at the SoftLayer account data type, we have to say virtual guests, even though we're calling it virtual guests here. We say virtual guests. The virtual guest host name needs to be test host name. And it'll generate a SQL statement that looks like this. We have our select from virtual guest, where virtual guest equals account ID and all that. So where virtual guest account ID equals our active user account ID. That's a basic filter that's added from the API itself. So when you call SoftLayer account get virtual guests, this filter is already there for you. The one we're adding is this and virtual guest host name equals test host name. And so that's essentially what's happening behind the scenes when you add an object filter to your API call. So when building an object filter, the first thing you have to do is find the correct data type. The starting point for your filter will usually be the service for the method you are calling. If you're calling something like SoftLayer service get property, your object filter will start with property. So for example, SoftLayer account get virtual guests, our object filter is starting with virtual guests. SoftLayer hardware server get active tickets, property is going to start with active tickets. User customer get hardware. And you'll see this pattern a lot in the API request, which is why I'm calling out specifically. So step 2, find the properties that you want to filter on. Like object masks, object filters can have a lot of child properties that you need to go down into to select on the basic property that you want. So, for example, if I wanted to get all of the hardware that was attached to a specific backend router, I would make a filter that looks like this. This would be an API call request for SoftLayer account get hardware. So we start with hardware. That hardware has a backend router. That backend router has a host name, and that host name needs to equal BCR03A DAL10. This will give me all of the hardware that has a backend router that's BCR03 DAL10. So, step 3, we need to actually create the filter. One thing you should probably do now is bookmark this link. There's an article about object filters that goes into quite a lot of detail about the specifics and technical details of object filters, like the operations and a lot of examples, and always a useful page to look at when dealing with object filters. So first I want to talk about the literal operators, which are listed here. These are basically matching if the string of a column matches this text, right? There's a little regular expression going on here. You can have a direct equals, not equals, greater than equals, less than equals, starts with, does not start with, ends with, does not end with, contains, does not contain, lowercase equals, matches a regular expression, does not match the regular expression, not null, and null. And those are your basic operations that you can do with a single property. And in your object filter, you can have multiple different properties as well. So for example, property 1, our operation is going to start with something. And property 2, subproperty, child property is not going to equal something else. So whenever you add multiple properties to an object filter like you're doing here, these are ANDed together. So both of these conditions have to be true for the result to be added to your API response. So there's also some complex filters, and the syntax for these is very specific, and I'm going to try to highlight it for you. So an in filter, so we got virtual guest host name, which is an object filter object right here. This whole thing is the object filter. This whole thing. There you go. So we have our operation. We're going to specify in. And that operation is going to have options. This options is going to be an array of options. So this is one option. The option needs a name, and that name needs to be data here. The value needs to be an array of the strings for your in operation. Okay? The thing with in operations, though, is that they don't support some of the fancy filters. They only support direct strings, right? So here, our hostname can be hostname 1, hostname 2, or hostname 3. And those will all be returned from the API. And that's contrasted with the OR operation, which behaves very similarly, but the OR operation can do more complex operators like starts with and ends with. So here, our OR operation is the host name will either start with host or end with name. Either of those, I'll get a response back. But again, it has the same format. So we got virtual guest host name, operation is OR, has options, which is an array of options. The value is also an array. Even if you only have one data point, the value needs to be an array. It's a requirement. We also have the not in, which is the inverse of in. So same basic thing, just the opposite. And an and operation. So opposite of OR, the host name needs to start with host and end with name. Or this one was starts with host or ends with name. Then we have our date operations. So date operations can be incredibly tricky. The date format is this, which is an Oracle notation. But you can also use sysdate for if you want to have a relative time. Sysdate is basically the equivalent of saying now. So, for example, we want all the virtual guests that have a provision date greater than sysdate minus 30. So that's going to give us all the virtual guests that were provisioned within the last 30 days. We also have between date. So we can get the provision date between. And this operation has options again. Options, always an array. We have two options here, the start date and the end date. So here our options have a name, which is date, a value, which is an array, and the date format, which again matches here. So our two dates, and that'll give us all the virtual guests between these two dates. And we also have greater than date and less than date, which I didn't show you less than date, but it's the same thing, just says less than date. Virtual guest provision operation, we say greater than date, has one option, name, date, value. Again, the value is an array, and we have our date string. So all the date operations, less than date, greater than date, between date requires two options, start and end, and is date, which will match an exact date. One of the things you can also do with object filters is sort the results. One thing to keep in mind, though, you cannot filter and sort by the same property. You have to filter and sort by different properties. In general, you should also sort by properties that have an index. And unfortunately, there's no way to know that through the API documentation. But a good value to sort by is almost always the ID property. ID is good to sort by, and any other string properties are probably good to sort by. So not all queries have a default order. And one of the tricks with that is subsequent queries might result in different order of the API result. And this is problematic when you're using result filters to page through data. And the only way to figure that out is when you're paging through the data and you realize that you've got multiple results of the same property. And this is kind of a thing where SQL will, between different queries, choose a different index to pull the results from based on some of the other queries that came in or something like that. So the way you prevent this is by forcing an order with an object filter. And so this is what that would look like. So on virtual guest, you specify the ID property. The operation is going to be order by. Options are going to be, again, an array of one option. Its name is sort. Its value is an array called DESC for descending. There's also the ASC option for ascending. And that's basically what you're going to put in here. And this will get you your virtual guest results in descending ID order. And that order will be the same between queries every time. It's also possible to sort by multiple properties. And for this, you're going to add the option called sort order to your object filter. Generally, you don't need to do this, but it's something to keep in mind. So for example, here, we're going to provision by virtual guests. We're going to sort by provision date. So operation order by. Options, we have two options here. The first one is going to say descending. The second one is going to call sort order. Its value is going to be an array. And the number in the array is going to be the priority of the order. So 0 means it's going to be the first column we're going to order by with. So if we have multiple virtual guest provision on the same date, we're going to also sort them then by max memory. So order by ascending, the sort order here is 1. So that's how you would sort by 2 different relational properties at the same time. So when talking about object filters, one thing you also need to understand is result limits. Result limits allow you to set a maximum number of results from an API request. The result limit, however, is important to understand, is applied after the results are retrieved from the database. So it does not reduce the amount of work the database has to do, but it does reduce the size of the payload sent to you. So always use an order by filter, usually on an ID column when using result limits. Like I mentioned earlier, not all API methods have order by clauses imposed on them on the back end. And so if there's not a default order by clause on the API method you're using, different API calls can have a different result ordering. It'll have the same results, the order will just be different. And that's problematic when you're using result limits. So for example, if you're calling SoftLayer account get hardware, your result limit, this is a URL encoded comma. So your result limit will start at 0 and give you 2 results. Without an object filter on this, calling this multiple times might get you different results. So that's just one thing to keep in mind. If you want the results to be in the same order every time, you need an order by object filter. So here's how you would specify the result limit with an XML SOAP request if you need it. So here we just have our name result limit, value has a limit is 10, offset is 5. So same basic thing. We got our result limit header. We say our limit 10, offset 5. So in conclusion, the object filter article is definitely a must read, which contains all of these examples and a lot more, and detailed usage of how the object filters work. Filters that are incorrect will be silently ignored. So make sure your object filter is actually working before you assume it is. And anytime you're using result limits, always use an order by filter to ensure that you don't get duplicate results between queries. And with that, thank you for listening. I hope you learned quite a lot about object filters. And have a nice day.